Well, welcome back to TJ's Probably Not Going to Fix Something. But I was editing the video while I was waiting on parts for this device, and I realized that I didn't even record the intro where I tested it. And so I'm going to have to do that now. When I initially got this, the seller said that his kid had spilled liquid on it, and it never worked after that. He said he tried to dry it, and it never worked after that. And so when I got it, I tested it. It didn't power on. When you connected a charger, although I didn't have a charger, I was just using a mini USB, and I wasn't even sure that is how you charge it. But in any event, it wouldn't do anything. So we will pick up this video with me trying to figure out what the input voltage is on this device. So I found this. It says it said 5 volt, 1.6 amps or something like that. So I just don't know if that, I don't have a box and I've never used one of these. So yeah, 5 volts, 1.6 amp. I don't know which one of these is the charging port. I'm assuming it must not be that, it must be this. But I don't have an adapter. I'm just going to take it apart. I think somebody's already taken this apart. So what is this? What is that? Okay, so this is the battery. Judging by the lettering here. Dude, how does this thing come apart? Well, maybe there is a teardown guide. It's been up a little bit, but I got it all. Alright. Circuit card. Do we see water damage? I'm going to say we do. We do see some water damage. Well, that doesn't look too healthy. I'm going to have to clean it. Yeah, and that is the power board, now that I think about it. As you can see, we have I can't tell what this is. I think that just flips up. It's hard to tell because of the glue. Alright, that's out. So I think this is probably going to be the bulk of our issues is going to be on this. So I think the best thing we can probably do is clean it and see what looks terrible after we're done cleaning it. Yeah, I think that's a pad coming off of there. I think some of those are pads. And I can't do nothing with that. I mean, I don't know if they're just test pads, hopefully. If they are falling off, hopefully they're just test pads. Let's look on the other side. So we have some crud right around here. That doesn't look very healthy. Yeah, this side of the board's a little more Is it me, or does that look like it's worn away? Let me see if I plug this in, if it'll give it power or not. If I see any current. No. Alright, so we're not pulling any current at all. Maybe I should check on this side for voltage. Okay, there's 5 volts coming in. I don't know where that goes. I don't know where it goes. So the reality of the situation is I don't know where that goes, and I'm not going to be able to repair that trace. I want to say that's a filter, or not a filter, but I want to say that's the crystal, but I don't know where that other thing goes. I don't know where it goes. I cannot figure it out. So I guess we're gonna just hope it friggin' works, you know? Where's that? Right here. Oh well, but we got that one connected. So maybe we can see if it pulls a little current now that I've repaired that trace. There may be other traces that I'm missing. All right, let's see if we consume any current now. No, we're still not consuming any current. And that may not have had anything to do. You would think that there would be, I would need to get some sort of voltages on this chip. That chip is probably some sort of charging type circuit, you know? I don't know where ground's at. Is there any voltage on this? No. There's no voltage there. So this is definitely ground. So here's what we're going to do. We're going to unplug it, right? We're going to go to resistance mode. I'm going to find a ground, and then that way I'll be able to. So this side of this capacitor is the ground. So we got 1.5 volts here. So we got 4.83 volts there. And 3.3 volts. No, that's not. I need to pay attention. There's 0.3 volts there. So we have voltage coming to that chip. Let's try to put this back in here. I mean, I'm assuming you can charge from this. I'm assuming. I don't know enough about this to know for sure. Still not drawing any current though. Why are you not drawing any current? Let's set that to the side for right now. Can we take this thing apart further? Can we take these out? Oh, I think I just snapped something off the board. That's not good. Hopefully I didn't damage anything. What in the world? How do you get this out of here? How do you replace the battery in this? So if the battery goes bad, it's just done? I mean, is that what we're gonna, is that how you designed it, Bose? You know what, dude, I wish this thing could pull out. Oh, thank goodness. Oh, that's loose. Okay. That looks super clean, and that looks like it's going to a speaker somehow. What is this right here? Does this come out? If I could get this board out, I could then try to charge the battery manually, and then I could plug it back in and see if it works, you know? Yeah, this board was the only thing that I found that has corrosion on it. The rest of this is clean as a whistle. I just need to figure out how to get this out of here. Okay. Hey! Oh my goodness, uh-oh. I'm fine. Can I take that off? No. Oh no, does that slide out? Does that slide out? It does. Oh, look at that, bro. Very nice. Okay, so we have the speaker assembly. We have our front panel board inside here, which I'm 100% sure there's nothing wrong with that. So now this is our battery. If I take my multimeter and I go from here to here, I get a negative voltage. So is there, okay, so this is positive. I should just look at the friggin' symbols on the board, you know what I'm saying? And this is negative. If I were to take 1 volt and 500 milliamps, right? And I were to, just remember, don't do this at home. Old people can take a little more risk sometimes. So I'm gonna turn my power supply on, and I am gonna come here, and I'm gonna go here, and it's drawing no current at all, no current. So I'm assuming that this pin is some kind of sense or some kind of communication that occurs to, because the battery might be on lockdown right now. Well, let's increase the voltage some. Let's go to like 3 volts and 500 milliamps. Still drawing no current. I think this battery might be locked. In which case, I can't really do anything about that besides order another battery, but yeah, still nothing at 4 volts. And this is a 7.4 volt battery. I think the battery, all right, so max charge voltage, 8.4 volts. Output voltage is 7.4 volts. I don't know. Could it be that I'm not charging it with enough voltage? I don't know. Let's go on up to 6 volts and see what happens. We're gonna put red, and we are gonna, the voltage increased to 6.69 on the power supply. Why did it do that? I'm pretty sure this is probably dangerous, but okay, so now we have 5.92 volts in the battery, whereas before we had nothing. So that did something. All right, I want to get this out of here, but it's got this rubber thing that protects the ribbon cable from water damage. And I'd like to be able to remove this. All right, that's out of there. So now this, I think, plugs into here. You probably can't see it, but like that, right? And then this plugs into here like so. I think that goes like that. And then this, there was something else that I'm missing. there's something else that I'm missing. Is there another board that I put? Oh, here it is. So this plugs in here like this. And so this is just for the speakers, I think. The speakers plug into here. Yeah, so we don't really need, I don't think we need that. I'm just looking for signs of life, you know? Looking for signs of life. So that's plugged in. Oh, there we go, look at that. There we go, so the battery's low. All right, so how do you cut it off? So the battery is unlocked now, but I still don't think this board is going to, not this board. I don't think this board is going to do any type of charging. Maybe now that it can detect the battery and I've cleaned the corrosion, I need to find something to set over here so we don't short anything out. So we'll do that. And this is USB out. So will we get any current now that the battery is unlocked enough to consume current? No, we don't. So there's still a problem with this. I think all the rest of this is good. I think it's just this. But again, I don't know if I have even the right charger on here. So I'm fairly certain that ribbon cable's okay. So yeah, I guess let's just continue to look at this and see if we can't figure it out. All right, so let's talk about some of the things that I've already done on this board. It was hard to record some of this stuff. I think I recorded myself fixing this connection here, and we ran it through the board to this capacitor. I don't know where this is defect, or this is broken. I don't know where it goes from here. On the other side of the board, I've had to fix a small trace down in here to connect it to this capacitor. I've got a wire running up through here because there used to be a pad here, and on the back of the board it was somewhere in here. I can't remember exactly where, maybe right here. This trace that went from this capacitor was broken all the way to here, to whatever this component is. I'm assuming that's a capacitor, maybe, I don't know. So yeah, so I mean, there may be other traces that I can't find. I've repaired a lot of the trace damage on here, but it's so small, and with, I hate to say it, I think I'm reaching the limits of what the Andon Star 407 can do in some situations, because I can zoom in, right, super far, and I can view, but I can't, it's hard for me to work under there with a soldering iron. Yeah, I've taken that capacitor off and put it back on. I don't know if the capacitor is good. I don't know if there are any shorts. This is just a very difficult task. But what I did do was I sucked it up, even though I didn't want to, is I paid $49 to purchase a working one from eBay. And I mean, it's a lot of money for this little thing, but I really, really want to know if this can be fixed. And I figured this can help me. So one of the big questions I had was this pad right here and where it went. And I think I found that it goes right over here. Or no, it's so small I'm having problems seeing. So this pad here, does it go here? No. Does it go here? Yes, I think it goes to right there. So what I can do then is we can go under the microscope and we can solder a wire. So I've already got a wire on there. I'll have to take that one off. We'll take this one off, and then so we can go ahead and take our wire and put it through our hole here. And we'll just put it right there, I think. There's a little bit too much flux, but it'll be all right. And then we're going to take this one, put a little flux down. Now it's on there, I think. All right, so now that we know where that goes, and this other one's connected like it's supposed to be to the back side of the board, we should be able to hopefully plug this in to our battery pack, and maybe we can get some current draw on this meter here. Just maybe, hopefully. No, the yellow light comes on. Then it went off. I mean, it's flashing very dimly, but it's not drawing any current still. Okay, so I guess we're not finished with this board. All right, so one area that looks bad, because it is bad, is in here. There was a lot of corrosion in here, and it ate away this pad. So when you look at this on this board, you can clearly see that this capacitor is tied to this via, and this capacitor is also tied to that capacitor, and then these capacitors go into this chip here. And on our board, you can tell that if I get really close, that these two are supposed to be connected to this via, and then they're supposed to be connected here. So if I ohm from, it's so hard to get in here, man. If I ohm from here to here, I get 0 ohms like I should. But if I ohm from here to here, it's an open. So I'm going to run a wire between those two and see what that does for us. I'll try to record myself doing it if I can. I can't tell if that's on there or not, man. All right, I think that's on there. So that is that chip. And then this goes to this wire. And I think we are good. Let's plug it in. So I finally realized you can just pull this out of the big metal case, and so it makes it a little bit easier to do things on. But so we are going to plug this in, and we are going to plug in and we get nothing. Dang, dude. I don't know what else to do. I mean, I have fixed everything that I can see, short of removing every component on this board. Let's put in the known good board. I'll show you what the difference is, right? So if I plug in this is the known good, and I plug this in. So now notice the current meter. And the red LED illuminates on the thing, and it's charging at 920 milliamps. So almost a full amp of current is being consumed by the battery. And that's what this broken one's supposed to do, but it does not do it. And this is a proprietary chip, so it's not like you can find. I can't figure out how the chip is supposed. I can't find a data sheet for the chip. So I don't know what's the output, what's the input. We got 1.5 volts there. Nothing there. Yeah, I just don't know, man. I don't know. I suppose I could put the other one in and gently probe. Okay, so that was different. 4.23 on that. 3.9 volts on that one. .6 volts here. 1.6 volts there. So that was definitely nothing. 4.23 volts there. Nothing. 1.6 volts there, but I wasn't getting anything on the other one. .2 volts. 1.6 volts. So I've traced out on that other board that I'm supposed to have 3.2 volts here. That 3.2 volts is felt here, and then that 3.2 volts should be felt here and through this component, which I'm assuming is a resistor, maybe. But when I try to flip over to the vias on the other side, well, they're covered by this connector. So we have no voltage on the drain, and on the gate we have a positive 4.7 volts, so it's never going to cut on. So the question is where does that ground come from, and why isn't it working? So I guess that's the next step to figure out. When you look at these here, this is a PNP transistor. That means on the base of the transistor, you need to have a lesser voltage than you have on the emitter to output anything from the collector. So in the working one, when I have this connected to this Bose main board, I have like 25 millivolts here, and I have like 4.3 volts out, and obviously this is your voltage in. If I do not have this connected to the board, then I have like 4.7 volts here, right? So in order for this transistor to turn on, I have to decrease the voltage here. And then that is actually tied to here. It's tied to here. It's tied to into here. So when this is not connected to the Bose main board, I have 5 volts here, I have 5 volts here, and I have 5 volts here. When I do connect it to the Bose main board, I have 5 volts here, 5 volts here, and this drops to 0. So I don't get it. And the only other place this runs is to right here. It comes through this via. There is a 100 k ohm resistor here, this capacitor, and that's it. That's where it ends. And this is the ground. They're tied to these legs of the ribbon connector. So I just touched up the solder here. I don't know. It was ohming out, but you never know. I'll give it a try real quick, see if anything changes. And nothing changed. I didn't think that it would. So this may be a bad idea, but this will at least get a a ground where there's supposed to be a ground. So I'm going to plug it in without plugging it into the main board. So it should think it's on now. It's plugged into the main board. So I'm going to plug it in and hope nothing smokes. Yeah, that worked. It drew current. It's not supposed to draw current when it's not plugged into the main board, but so I am going to plug it in again, make sure nothing's smoking. I don't see anything smoking. So it's drawing the correct amount of current that the other one draws. So do I have the 3 volts up here now? Still drawing good, steady current? No, I do not have the 3 volts I'm supposed to have right here, 3.2 volts. I don't have it. So then is the 3 volts a different issue? Dude, this may be a bad idea, but I think I'm going to plug this into the board and see what happens. This may be a very bad idea, but at this point I don't know what else to do. So we're going to watch for LEDs to illuminate on this thing and hope nothing smokes on this board now. Either way, if I destroy this, I'm still putting the video up. I mean, it's not that big of a deal. It's a learning process. I don't see any lights. But I did get 41 milliamps of current draw. 38 milliamps. As you can see, 40 milliamps. All right, so let's do this. Let's plug in the battery. All right, so you can see the lights are flashing. What happens if I plug this thing in? Will it charge the battery? If it turned yellow? No, it's not doing it. It tried to, but it didn't. It didn't charge it. Well, let's see if that 3.2 volts is present now. Is it right here? No, I still don't have my 3.2 volts. Okay, so that 3.2 volts must come from this board. So I've removed that jumper I put between this PNP transistor and ground, because what I think is supposed to happen is I think this is a crystal. This should have 3.2 volts here, and then that 3.2 volts is then felt on the main board, which then sends back the signal to turn all of this on to feed our chip here. And I think that's the issue. I'm missing this 3.2 volts, and therefore the rest of the voltages that the thing requires is not being produced. So I traced down and I figured out that I have 3.2 volts that is felt here, and I'm assuming that 3.2 volts is being originated by this chip right here. So now I have to trace. There's not much to it on this side. It's just this chip, and you have this pin. It goes to this capacitor, and then through this via on the other side of the board, it comes up right here, and this ties to this resistor, which I don't know where all that goes, and it comes back up here. I'll trace that in a minute, but then it comes down through here, and then to these two capacitors and this resistor in parallel. And this is a 100K ohm resistor, and so then it comes out of that, comes down. I don't think it's tied to this. It comes down through here, comes through here, comes around, and then it comes to here. So I think I'm going to ohm from here to here, because I don't know if that's a pad or if that's something else. Yeah, so that's good. And then it comes and it goes out of the connector. So then I have to trace the other way. It we know it goes through this, I'm assuming again, this is a resistor. That's my assumption. It's a 100K ohm resistor, it looks like. So then it comes through here, and this old raggedy looking capacitor right here. And then it comes down. So I'm pretty sure I have connectivity between here and here, and I do. So now I just need to trace where it goes from here. I think it comes up underneath this chip. So I took that chip off, and so it comes up. It comes up right here. That's where it comes up. So it comes up, and then so if I'm tracing the circuit out, we have this path that comes through this resistor, down through here, right here, and then comes up right here on these two pads. So if I remember correctly, I was getting no voltage on these two pads, and they're both, but these seem to be, they either feed the chip or the chip feeds this. I'm not sure the order in which that occurs. Then it goes up to this capacitor right here, and this, if I'm not mistaken, is not shorted to ground. I don't know if I've checked this before or not, but no, it's not shorted to ground. I'm not exactly sure where to trace it from there, though, you know. I'm running out of leads. I'm running out of leads to pursue. And I think I might have found something. I don't know if it's relevant to our issue, but right here, this should be connected to this, and it is not. So that trace is broken, so I need to figure out where it goes. Bro, I'm gonna tell you right now, you can tell that this is bugging me, because I don't know if I should have gave up on it a long time ago, or I found it right here. There we go. All right, so the chip's back on. This is fixed. So I have a tremendous amount of trace repair on this thing, man. I really do. I mean, I think I'm up to like 12 or something. So I don't know. We'll plug it in and see if that made any kind of difference. Hopefully so. And remember, I disconnected the wire that was connecting the thing. So I don't know if this will make a difference or not, but it might, hopefully. Look at the current. I think that's it. So do we have 3.2 volts? I don't think we do. Plug in the battery and see, pulls current. All right, the light went yellow. Now I'm not drawing any current. I was just drawing current, but now I'm not drawing any current. What in the world is going on? So I'm drawing current with it plugged into the main board. I don't see any buttons or any lights on or nothing. But if I plug in the battery, then I'm not drawing current for some reason. So no lights illuminated. Orange light comes on, but it doesn't draw any current with the battery connected. Dude, I thought we were good. How many problems? All right, I'll keep looking. So I have spent a tremendous amount of time trying to fix this little board. And I think that the issue is, I don't know if maybe this little chip down here is faulty. I can't take it off because I'll melt all of this. So, or I mean, I might be able to get it off, but I don't have one to replace it and check. But I did touch up the solder around each of the legs, and I'm not getting the voltage on the big chip there. And because I'm not getting that voltage and I'm not getting the 3.2 volts, I think that is not telling this transistor to turn on to produce the 4 volts here. Or maybe it's the reverse. Maybe something's supposed to tell this transistor to turn on, but I just don't know where that thing comes from, because it's like it stops. So something has to tell this to turn, to put a ground here or put a lower voltage there. And it's not doing that. I think it just had too much trace damage and corrosion damage for me to fix it. I tried very, very hard though. I hate to admit defeat, but I don't want to keep doing stuff to this and then plugging it into here and then end up breaking the whole thing. I don't want to do that. So I am going to put it back together with this board here, and we're going to call it done. At least it'll be fixed, and I'll give it to my wife and see if she likes it. So I will be back when I have this thing put together. Well, in my zeal to repair that stupid power module, I believe I have killed the entire Bose with my experimenting. Because when I plug it in, I hear that, I get no lights, current draw is stuck at 0.094 milliamps. So I took a device that was working except for the power module, and I have broken it even more. This is why you shouldn't experiment with things that you don't know about. So I guess that's where we're going to end this video, man. I said I was going to upload it, and I will. I got to stop experimenting, bro, even though you learn from it. And to show you, it's this chip right here. That's the chip that I shorted with my experimenting. I took something that was alive and I killed it because I'm a moron. And if you notice, the current draw is 88 milliamps and before it was like 37. I'm an idiot. So I would be remiss if I ended the video and didn't tell you what experiment I conducted that ended up killing this IC right here, this ARM IC or whatever it's called. The whole time I was trying to figure out, A, why I wasn't getting 4.7 volts here on the collector of this transistor, and B, why I was not getting my 3.2 volts. I could not figure out if the 3.2 volts was originated by this chip. Was it the catalyst for providing the ground that would turn this transistor on? I couldn't figure it out. So what I did, and this is the absolute last thing, I'd already made the decision that either this is bad or this is bad, or there's more trace damage that I can't see internal or whatever. So I said, you know what, one last experiment is I'm going to inject 3.2 volts into the power board, and then I'm going to see if it draws any current, if anything happens. And so I had this disconnected from the rest of it, and I did that, and it drew no current. I checked the voltage here, and I wasn't getting 4.7 volts there, so I'm like, okay, well, I'm going to take one more risk, and I'm going to actually plug it in to this board, or to the main board here. And that's the mistake I made, because when I injected 3.2 volts here, that 3.2 volts, remember, is felt right here, and it either goes into this ribbon cable or it comes out of the ribbon cable. I don't know which way. I don't know what produces what at this point, and that's the mistake I made. So that was the last experiment that I did on this board. And then when I went to put it back together, I noticed it was drawing a constant 90 milliamps, and that was it. And I was like, uh-oh, something's not right. And then I broke out the thermal cam and figured out that this is drawing 90 milliamps right from the get-go, and it wasn't before. It was only drawing like 37. So that's what I did to kill this main board. And so don't do that. Don't be a moron like me. So I took $100 device and I just bricked it because of my own stupidity of wanting to fix a horribly corroded power board. You know, most normal people would be like, oh, whatever, dude, I'm not fixing that. But no, I wanted to fix it. So anyhow, so now I have a completely dead system, and I feel absolutely horrible in my soul about it. But I'll get over it. Anyways, y'all have a good weekend.